Now, there's some special types of graphs that you need to know about. So we're now going to start talking about trees. So a tree is a connected graph, but it has no cycles in it. Okay, so for example, from this one, this graph isn't a tree because there are cycles going around, but if you took the cycles out, this counts as a tree for this graph. Okay, so it's all branchy like that. What we call a spanning tree is a graph or a subgraph which includes all of the vertices of the graph and is a tree. So something like that joins up all of the vertices. It is a tree, there's no cycle, so this one is a spanning tree. We'll come back to these later on in future packs. Next, a complete graph is a graph, a simply connected graph in which each node is directly connected to each other node. So we denote these by K with a little subscript. So K3 is a simple, complete graph of 3 nodes, which is a triangle. K4, and these are all joined up to each other. Like that. And K5, pentagon, and all joined up to each other. Like that. This is K5. It wants us to list the number of arcs. So for this first one, we've got 3 arcs. This next one, you count those up, we've got 6 arcs. And for this last one here, we've got 10 arcs. What you notice is these are triangle numbers. So Kn with n nodes will have a total of a half n minus 1 arc. Finally, for this page, 2 graphs are what we call isomorphic. If they are exactly identical, mathematically the same, so they might not look the same, but if you think about their connections and the number of their orders and stuff, these 2 graphs are exactly the same. So if we have a look at first the orders, A has order 1, E has order 4, C's 2, D's 3. E's 2, it's the same in this one over here. 1, 4, 2, 2, 3. And also, if you look at what's connected to what, so A is connected just to B, directly connected. B is connected in both of them to A, C, D, and E. Works for both. B is also connected in the second one. Let's check C. So C is connected to B and D, which works in the right-hand one as well. D is connected to B, C, and E, which it is again in the second one. And finally, E is connected to D and B, which again it is in the second one. So these 2 are exactly the same mathematically. They're isomorphic. There's lots of different things we could draw for this one. So draw 3 different graphs, each with 4 vertices of order 1, 3, 3, 3. Let's start off with one of order 1, and then if I join these up, that's got order 3. Doing a double connection between these now will give me a graph that satisfies this question. Now I could do a similar thing with a slight variation on this one. Made that order 3. I want to join this up. But instead of joining this up with a double connection, what I'm going to do is put a loop on each of these. And now these are both order 3, but it's a different graph to what we had before. In fact, our graph doesn't have to be connected. I could do this. I could have one of order 1 and one of order 3 at the bottom with that loop. And then I could join these up 3 times to make these of order 3, or you could put some loops on or whatever. There's different answers you could have for this.